Welcome! In this module, we're going to start talking about integrating and formatting our data to prepare it for analysis. We're going to begin by talking about how we can modify strings by concatenating, trimming, changing the case, and using the substring function. We're also going to spend a few lessons talking about date and time strings specifically. There's actually a surprising number of ways those can be formatted, which often leads to great complexity when making any adjustments to them. We'll also spend some time discussing how we can use case statements, which is the SQL version of an if statement that you see in most programming language. Using case statements is one of my favorite things, so I hope you're really looking forward to that discussion. We'll wrap up this module by discussing data governance and profiling, and end by going over some fundamental principles you'll need to consider when using SQL for data science. We'll go over some tips and tricks that will leave you with more of an understanding of how all the SQL material we've discussed in this course should be used in the data science context. Alright, I'm glad you've stuck with me this far. We only have a little further to go, so let's get to it. Data scientists often have to integrate and harmonize data from a variety of sources, and the data that you're integrating isn't always formatted in the same way. This can obviously cause problems when you're trying to blend this data together. Knowing a few tricks and how to change the fields you're looking at, whether it's a string or date, is very useful to know as you start to learn to combine data from multiple sources together. Over the next few lessons, we're going to go through a few ways that you can start to manipulate the data in order to blend it to make it work for your analysis. In this video specifically, we're going to talk about things you can do with text strings. At the end of this lesson, you'll be able to concatenate or combine text strings together, trim text strings, use the substring function, and change the case of your strings. Alright, so let's begin. Strings are really important because we're going to encounter them a lot in text and categorical data. Strings pop up everywhere and are pieces of data we frequently work with. It's important, as we've discussed before, to retrieve the data in the format you need. So if there's something that you can process and do on the server versus your client application you're working with, then it's best to go ahead and do it there on the server. SQL supports a couple of different string functions. It can concatenate, which is a fancy data science word for linking things together. It can use substrings, or SQL can trim the beginning and end of the string. So let's discuss a few examples to learn these various functions. Let's go over concatenating something first. This function is really helpful when you're coming up with a unique ID for something. Maybe you want to concatenate the first couple letters of a person's first name and the first couple letters of the last name. Or maybe you just want a unique category or field. To do this, we're going to do is use the pipe or vertical bar key. On most keyboards in the US, this is typically right above the backslash key and is usually accessible by holding Shift when hitting this key. In this example, I want to concatenate the company name and the contact name. What I've done is I've used my select statement and I have pulled apart the company name and added to it the contact name. You can see I called the company name here. Then I use the pipe to indicate that I want to concatenate, and then in parentheses I indicate what I want company name to concatenate with. In this case, it's contact name. Here in this example, you can see I pulled in the company name and the contact name just so you can see them individually. Then you can see on this side the ultimate result from the concatenation. It's important to know that the different relational database management systems use different formatting than this. SQL Server, for example, uses the plus sign instead of a pipe. Just be sure to look this up based on the type of application you're using. The next thing we're going to look at is trimming our strings. With this function, you can either trim everything off the front and the back, or you can just trim it from the right or left. To do this, we're going to use the simple function called trim. We also have rtrim and ltrim for right trim and left trim, respectively. Here you can see my string is the thing that says you the best. And there's trailing spaces before and after that. When I put it in parentheses and I have called the trim function before it, we can see that the end result takes care of all of the trailing spaces. This is just a really easy way to clean up your data, and that will save you a lot of hassle in the long run. Finally, we're going to work with the substring. Substring is a useful function that allows you to pull apart just a portion of the string that you're looking at. Again, we talked about creating multiple unique IDs. Or maybe you want to combine the first couple letters of somebody's name with the last few, or you're just trying to shorten a name because you only have so much space for it. If you use the function substr, it's going to return a specific number of characters for a particular position in the string. You can designate where you want it to start and where you want it to end. How this works is you write out the function substr. The first thing you're going to give this function is the string name. So where do you want it to pull it from? And then you want to say where is the string position. So that's what's the string starting position. Then what are the number of characters that you want returned? In this example, I'm going to look at the first name. Then I'm going to have my substring start at the third character, and I wanted to pull 4 characters starting there. As you can see in the first example with Nancy, there aren't 4 characters. It just gives me whatever it can fill in with it. Then you can see where it starts. It didn't give me the N or the A. It started with the second N, and then gave me this, NCY. The name Andrew is a little bit better example because I can see all 4 characters that I'm getting. But then if you go down to number 9, you can see that with Anne, I'm only going to be getting 2 characters. Another example of this is, again, if we wanted to just pull the first 3 characters of a person's name. Say I want it from first name, and I'm going to start with the first character and go all the way through the third character. Finally, let's wrap up this lesson with one more quick way to clean up your data. Sometimes strings need to have their case changed. You'll get into this information with the free-form fields or people's names. What happens is, some people use all caps, or some people will capitalize their first name. It gets messy. Just to standardize your data and make it so that you can do comparisons or blend it with another field, it's really helpful to change everything to either upper or lower case. For this, again, it's just a simple function. You're going to say upper and then the column name that you want to change to uppercase. An alternative function that does the same thing is ucase. Then to convert strings to lowercase, you can use the function lower. Okay, we've covered a lot in this lesson, so let's stop here. You should now know how to concatenate and trim strings, use the substring function to get a portion of a string, and how to change a string's case when necessary. In our next few lessons, we're going to continue our discussion of data manipulation, and we're going to move on to talk about date and time strings. Welcome back. In our last lesson, we learned about many things you can do with strings. We're going to continue that discussion here by looking at a particular type of string, dates. Date variables are tricky and can be difficult to work with because they can be stored and formatted in many different ways. But dates are something that we use in analysis often. And as such, you're having to restructure this type of data frequently. We also use dates for different time series analysis, and the time frame of the date you're looking at can be really important if you're doing any sort of clustering with your data. After this lesson, you should be able to describe the complexities of adjusting date and time strings, discuss some of the different formats in which dates and times are present, list and describe the 5 different functions in SQL that can be used to manipulate date and time strings. Let's begin. Working with dates is an important skill to have, but it is also one of the more difficult things when it comes to working with SQL and databases. One of the things to note again is each data management system uses its own variety of data type. Again, you should probably look it up and see what are frequently used ones and which systems you're using. For this, I'm going to be specifically going over SQLite, since that's what we're using in this class. But again, just remember to pay attention to this in case you're using a different database management system for your job. One of the things to remember here is, as long as your data contains only the date portion, your queries will work as expected. However, if there is a time portion involved, it starts to get a lot more complicated. What I mean by this is if you look on the right-hand side here, there's a lot of different formats. The first one, we're spelling out the day of the week, we're spelling out the month, and then we have the day and year. The other one, we're abbreviating the month, day, and year, and then we have a time, and we also have the time zone it's in. There's even Julian format. There's a lot of different formats. If your date column just simply has the date portion, such as 9/17/2008, things will work pretty easily. Things get complicated when we start to use those timestamps, which can contain hours, minutes, and seconds. Again, as we talked about, the most important thing is understanding how it's formatted before you start working with it. Let's go over that a bit more by looking at an example. If you query a date time and you say something like where the purchase date is 2016-12-12, you aren't going to get any results back, and this is because it's in this format that also has the hours, minutes, and seconds. Sometimes you need to convert it because maybe for your analysis, you don't maybe care about the level of detail. If you do, you can be very specific and say what you're looking for, but a lot of times we're just looking at things down to the day level. Knowing how to change this and manipulate it is important. To do this, we have some different functions that we can use to manipulate. SQLite supports 5 different date and time functions, as displayed on the screen. So you can pull out the date of something. If you're working with the timestamps, you can also just pull out the time. There's also the Julian day. There's a lot of different functions here that we can use depending on what we're hoping to do with dates. What you can see is that all of these kind of follow a similar format. You start with declaring your function, and then you do your time string and modifier. The time strings are what you want to extract from the date time function. As you can see here, what we have are a lot of different time strings we can use. We can extract the day and the month. We can extract the seconds, hours, years, and minutes. Really, any piece of information we're able to extract from that date timestamp. Then what happens after we add in our timestamp string and modifiers? There's also a couple of modifiers that SQLite supports. To go into a little bit more detail into this, the time string can be in a couple different formats, as shown here. I'll provide some resources for you. There's a lot of great resources on the web, and there's just one format that it has to be in. Just pay attention to what you're looking for and then how you want to format it. And the same thing goes with the modifier. A time string can be followed by 0 modifiers or multiple modifiers. Each modifier transforms that is applied to the time value is applied from left to right. The order is really important when you apply your modifiers, and keep that in mind when you're doing this. Okay, so that's an introduction to working with date and time formats in SQL. In our next lesson, we're going to continue this discussion by going over some more specific examples. This should help you understand how to use the functions we've discussed even better. So I hope you're looking forward to that. I'll see you there. Hi there. As you'll recall in our last video, we went over the basics of working with date and time strings. In this video, I want to continue our exploration of these topics by going over some concrete examples, because I really do think that's the best way to learn these things. So after we explore these examples, you should be able to use the strf time function, also known as the string format time function, compute the current date and use it to compare to the recorded date in your data, use the now function, and combine several date and time functions together to manipulate data in specific ways. Okay, so our first example is a really common one. You have a date of birth and you want to figure out the actual year and month or day this person is born. To do this, you can see that I've actually selected my birth date, and you can see that the format this is in our date time format. We have our year, month, day, hours, minutes, and seconds. Now for birthday, especially someone in customer information system, we usually don't know the hour, minute, or second that that person was born. Or a lot of times, these are even blank, and we want to get rid of them because it doesn't provide any value to our analysis. To do this, I've created 3 new columns. One for the year they're born, one for the month, and one for the day. This is also really helpful when you want to flatten out your data. You may want to create some different dimensions, such as years or months, to group it and aggregate it by. This will be really helpful in a scenario like that. To do this, you're going to use the string format time function. I'm going to declare the function, then I'm going to say the time string I want, and then I'm going to grab that from. My time string is that I want to select the year. I'm getting that from birth date, and then I'm creating my alias to call it as year so I remember what it was. And a similar thing happens for the month and the day. I'm just going to be using those different time strings to extract that. Here, you can see the results. Now that I've done is just take that one field and kind of flatten it over 3, but having separate columns for my individual year, month, and date. Another common thing to do with date and time is to compute the current date. This is frequently used in analysis because you may want to look at something to see how many days it has been since a customer submitted an order. Maybe you're looking at it from today's perspective. So let's say an order last happened 5 days ago, and I need to know what the current date is so I can calculate how long ago that was. Another thing you may want to do is to compute the year, month, and day from the current date. This is just getting a little bit more specific. To do this, we can use one of the modifiers, which is now. We're going to say select the date and then now. If you just take that and write it into your system, you'll see it will provide you the current date. I can also then compute the year, month, and day for the current date. Now I'm combining my string format time function and also using the modifier of now to get the individual year, month, and day for the current date. Again, another example shows you how you can even get down to the hour, minute, second, and millisecond for that time. How frequently this is used, though, is, again, going back to our example of the birth date. A lot of times we really don't care about people's birth date, but we want to know their age. In this example, I took my previous query where I'm selecting the birth date and I've separated out the year, the month, and the day, but I've also added a new column where I'm going to select the age. What I did is I took the current date, my date now, and then I minused it by the birth date. That return is the age is the number. In this table below, you can see that I now have my original column birth date. Then I have separated this data into these columns for the individual years, month, and day, and then finally I have my new calculated column for the age. You can start to see how when you combine these functions together, you can really do a lot with dates. Dates are so essential in any analysis. A lot of times you will really want to flatten out your data. So you're taking parts of that timestamp and computing maybe a second a time because you want to aggregate on that. For example, do we see a high volume of hits to our website at an individual second, or is it over the span of a certain hour? So being able to extract from a timestamp is so important to be able to do some of these types of analysis and aggregations, which is why we spend a good amount of time on how to manipulate dates and times in the last few lessons. We'll be moving on to another new and fun topic, though, in our next video. Welcome back. As we continue our discussion on data manipulation and transition to data analysis, we're finally going to get to one of my favorite topics in SQL, case statements. When you're conducting data science, you're always needing to transform variables or recode the data in order to help you with your analysis. As you know by now, most of our time is spent cleaning up this data. Case statements are really easy to start to do this. We use them a lot when we're doing things like when we're hiding coding or taking an individual categorical variable and creating its own column out of a binary variable. We also do it when we want to create different groupings. So a lot of times when we're doing some type of forecasting or predicting, we want to create bins of what we're going to predict. Case statements can help with all of these tasks, which is why they're great to cover, and we're going to do that in this video. After this lesson, you should be able to define what a case statement does, describe some situations in which a case statement is useful, explain what each part of the case statement syntax does, use a case statement using appropriate syntax, and explain how to categorize or bin your data. Let's begin. The case statement is a built-in function that mimics an if-then-else kind of statement found in most programming languages. This can be used in select, insert, update, and delete statements. The logic that the case statement takes is as follows. You're going to say case, and then when, and then you'll have a condition. Then after you say the condition, you'll put then, and what the result expression will be. So you could have multiple cases when it's a certain expression, and what you want the result to be, and that could go on for a while. When you're done with that, if the expression declared in the when part of the statement is not one of those cases, then, at your option, you can elect to say what else the result would be, and then you end your expression. This shows just an outline of what it would look like. Let's look at a simple case statement as an example. Let's say I want to reclassify my cities, and I'm interested in looking at just the Calgary cities. And so I want to create a new column that's Calgary or other for my city. To do this, I'm going to say case city, and then when it's Calgary, and I have that in my quotation because it's a string, then I'm going to classify it as Calgary. Also, I'll classify it as other, then I'm going to end this and I'm going to call the calculation Calgary. Here I also pulled in some additional information about the employee, the first name, the last name, their ID, and then I have the city. I pulled in the city so you could see if it's classified right. And as you can see here, that's true. And Lethbridge is classified as other. And then you can see Calgary, there's a classification as Calgary. This is just a quick way that now I create my own binary variable for a categorical variable. Instead of calling it Calgary, I could have also named it a 0 or a 1, and this would have been a really great method for a lot of the algorithms that we use, especially in clustering, where you don't want to use categorical variables. So you transform that into the one-hot encoding. The only thing I would do differently here, if I wanted to do that, would be instead of calling it Calgary or other, I would call it Calgary with 1, and then other would be 0. You can also use this as a search though. For this example, I'm going to show you how you could add a couple of the cases together. Here what I'm looking at in the Chinook database is how I'm going to classify my tracks. I want to classify them based on the number of bytes they have. Again, we have discussed a little bit earlier in the course how we do this when we're doing predictive modeling or forecasting. So here, we may want to bin all of our small sales customers into one and predict their future sales, or large-scale customers into another, and so on and so forth. In this case, I'm going to be looking at the size of the tracks, and so I want to bin the bytes. Again, it starts the same way. I say case, I'm treating it just as I'm selecting another column. So you can see I have my select statement, I have my selected track ID, name, bytes, and then I say I want it to select the case. It starts when bytes, but this time I have an expression, so when bytes are less than 300,000, then I'm going to classify this as small. When the bytes are greater than or equal to 300,001 and less than 500,000, then it's going to be classified as medium. And then I have my large category, which would be anything greater than or equal to 500,001 bytes. I also put on here the else, and I put that for other. You could leave this blank, and it will just classify back as a null. But this was just in case there wasn't something I caught. However, the way we've written this should have caught everything. You can then see that in the table, I filled in the blanks, and you can see how it's starting to classify this. So this is just a really nice way to start to create bin groupings for my different statements. Another example of what you can do, instead of saying when it's greater than or less than something, is calculate another field. So, for example, let's say you have 2 different periods and you want to classify and count the sales by those periods. You could say when the period is between 1 and 5, then the net sales, else 0. This is creating a condition that is based on, and you can classify sales during that period. So just something to remember is that the then doesn't always have to be a word or a number. It can be a field from another column. All right, so I just took you through a few examples of what you can do with a case statement. Again, this is something you really want to learn so you can understand all of the uses for them. Honestly, it'll probably surprise you how often you'll use case statements in your work and what you're able to do with them. So I definitely recommend extending what you've learned here by reading up on the resources and articles regarding case statements. Then be sure to practice and start using them and explore all you can accomplish with case statements. So far in this course, we've learned a lot of statements and functions and have gone over quite a few tips and tricks that kind of help you put everything together. In this video, we're going to talk about another useful feature you can keep in your back pocket. We're going to talk about using views, including what they are and how you can use them. Sometimes when you're in a sticky situation and don't know how to solve it, views can really just help you simplify the queries you write. After this lesson, you'll be able to discuss how and when to use views with your queries, explain how to use the as function with views, and explain the benefits and limitations when using views. So as we've talked about earlier in the course, we're always combining data from multiple sources or transforming it in some way. As you know, sometimes things like the order of operations can get a little tricky. Instead of creating a whole new table, sometimes we can create the illusion of a table by using a view. A view is essentially a stored query, and it helps us clean up our queries and simplify what we have to write. In a view, you can add or remove columns without changing the schema. You're not actually writing the query to the database or anything. What you're doing is you're kind of storing it for the time being. This is really helpful and pays off when we use it to encapsulate queries. The syntax for this is you're just going to create, and you can either specify a temporary view or just create a view. You can also add in if not exists, so if it doesn't already exist, then you have the view name and you state what the conditions you want to go into the view. An important thing to remember with this, again, is the kind of illusion that you're creating in the table. It's only stored for the duration of a session, so it's important that if you're using the view in your query, you can save the query. And then you come back, and then if you come back the next day and start a new session, and you're having errors in your queries, it's probably because you didn't create that view again. So just keep this in mind. It will save you some headaches and time in the long run, but a view won't be a permanent fixture in your SQL code. Let's take a look at an example. Let's say I want to get a count of how many territories each employee has. If you look at our ER diagram, this information is separated out from each other. I'm going to create a view so that on that view, I can just run a simple count on the number of territories. So here, I will create my view. Then for my view, I'm just going to call it as my view. Then the as is really the select statement. Remember how before we've used as an alias to say what we want our column name to be? You can think of a view as a whole table, but now you're saying, what do you want in all of that table? Your as is going to be a select statement for what I want in that view. I'm going to indicate all of the columns I want and where I want those columns from. Here, even in my view, I'm going to join multiple tables together to create this. You can then see that if you execute this query, you should get a little status update that it was executed. To actually view the data though, you'll need to use a select statement. For this, I'll just add select star from my view, and you can see the table output there. If I didn't want this view anymore, when I hit in my session, it will go away. Or I can just drop the view. So to do this, I will just say drop view and then the name of my view, which is my view. Now that I have my view out there, I can actually perform even more queries on top of that. I can now take that view and I can select the counts and the territory descriptions. For example, this will give me an idea of the counts of how many territories that each employee has. I can then group it by the employee's last name and first name. Now I can see the total count for each territory of what each employee has. This would have been a little bit more complex to do if I tried to do it all at once, but creating view just made things really simple. The beauty of the view is that it can be used like a table, but it's unlike a table in that you don't have to have ETL or run ETL on any of the data. This helps a lot by encapsulating complex queries or complex calculations that you're trying to write. It can really help simplify it. It can also be used in pretty much any database except for stored procedures. Views are really most helpful if you need to join a set of tables and you're having trouble getting calculations, particularly those complex ones dealing with the order of operations in the right order to get the output you're looking for. Another benefit of views includes different securities or write capabilities. We talked about not being able to write data to an environment or to a particular database. Views are helpful because you're creating a view of a table but not actually writing data to that table. This is a way to get around some of those database writing limitations. Another thing that views are helpful for is to create a stepping stone in multi-level queries. For example, let's say you create a query that counts the number of cells that each person has made. You could then write a query that groups the salespeople into a particular group. Then you can count the cells of that group as well. It just creates this multi-level dimension that you wouldn't have been able to do elsewhere. And then it also helps so that you're not transferring any data through an ETL process. So as you can see, views are really useful. Just remember that views are temporary and are only going to be good for that session. If you're reusing a query, you'll have to recreate that view in another session as well. Views are definitely something that will come in handy if you're in a particularly sticky situation or having some trouble with your calculation. It can definitely make things a lot easier for you, so I encourage you to give them a try and put them in your queries. Welcome! We're going to shift gears a little bit in this video to talk about perhaps a less exciting but vitally important topic with you, data governance and profiling. Now, data governance and profiling is not something that we're actually using SQL for, in the sense that I'm going to teach you a new function or anything, but it's so important when it comes to writing really clean and quick queries, where you're getting this data and how you actually want to get it back. So I want to touch on this a little bit because although this class is about SQL for data science, it's really about the application of using SQL for data science. An important part of that is understanding data governance and being able to profile your data. So after this lesson, you should be able to define data governance and profiling, explain the importance of data governance and profiling in your data appropriately, and discuss some methods to profile your data. Okay, let's define data profiling first. Profiling your data is where you're looking at either descriptive statistics or different information on the data. And the reason why this is important is because we've talked about how you need to understand your data first before you start querying it. So profiling is a great step to begin to understand your data. It's really simple things that you can do to start to profile your data. Some of the things you can do is start with just understanding how many rows are in the table. You can also look at when was the object last updated, meaning when did the data get refreshed and reloaded, because this may change some of your results. This may change the data that you need to limit it by. If it's getting refreshed nightly or in real time, do you need to set a certain date parameter, or are you okay with a consistent flow of data? So understanding these things is essential for understanding how you might want to pare down your data to get what you're looking for. You can also do some column data profiling. So for this example, just start off with looking at what is the actual column data type. Is it a date? Is it a timestamp? Is it a date stamp? Is it a string or an integer? This is going to change how you write your queries, for what functions you're going to be able to use as well. Although another thing to look at is how many distinct values are in this column. How many rows have no values in them? How many nulls are there? Is this something you need to be concerned about and deal with, or is this some another issue and some of the functions you're working with will take care of that? And then you have your simple descriptive statistics. Minimum, maximum, average, standard deviations, things like that are going to be really helpful in getting you to know your data and profiling it and understanding it. And the reason that this is important is because you need to be able to test your data along the way. So as you start to write your queries, test to make sure you're getting the results back that you expect. If you're doing a left join from a table that has 100 rows on the left side and then 50 on the right side, and you only get 50 rows back, well, you know you did something wrong, because it should bring back everything from the left side. It should at least have the 100 rows. Understanding your data can help you in testing, and that's why using some of these simple things to look at, such as number of rows, distinct values, minimum and maximum, can really help you get around this space and get you familiar with writing the correct queries in the long run. In terms of governance, this is really dependent upon what the data strategy is at the company you're working for. Some have really strict governance policies, and some are more open and free. In terms of a data site using SQL, it's important to understand what your read and write capabilities are in the different environments. Is there a sandbox you can play in and work in to do some of the transformations and things like that to your data? These are good questions to ask. This is really more so getting in contact with whoever manages this at your organization. But understanding the governance around the data and what you're actually able to do is important to know to keep your environments clean. This should go without saying if you've done any programming. But clean up after yourself as you start to write. As you start to really explore your data, you quickly type something and then clean something up and then try something else. Just really keep what you're doing and keep your work really clean. And then also understand what the promotional process is through your environments. If you created a model and you want to give those predictive scores and write them back to the database, what environments do you have set up? Is this something that you're going to be able to go through development, acceptance, and production? What is the process for that, and what are you writing it to? These are just a few little tips on how profiling your data and understanding governance regulations around them. But it's definitely important to look at this at your organization and find out what these governance policies are so that you know why something may or may not be working. Then you'll have the foresight to be able to write your queries and extract and insert your data into a table in the way your organization views as best practice. We've gone over a lot of different things you can do in SQL, from simple things and just pull some fields to joining multiple tables together, creating different views, and case statements. You have a lot of knowledge and are really well equipped with the few things in your toolbox to pretty much do anything you want in terms of extracting, inserting, and updating data. But I think the hard part in learning any programming language is really understanding how it all fits together. So with the next two videos, I want to take you through a few basic principles that will help guide you towards using SQL for your data science. Essentially, how do you bring SQL together for use in data science? After this video, you should be able to discuss the importance of really understanding your data when starting a new problem, as well as discuss the importance of really understanding the business needs before beginning a data analysis. These are just a few things that I use when starting a new problem. I think it's really important to know how to work through a problem from beginning to end. And using SQL for data science, what we're often doing is extracting the data from some storage system, analyzing it, and then maybe writing back a prediction to the database. This is usually centered around a question or a type of analysis that we're doing, a problem that we want to solve. I think there's a few principles that you can use in making sure that the SQL piece of your work is going through a problem from beginning to end and is successful. All of this starts with the data understanding. This is the most important step. This is why we spent so much time understanding and explaining modeling and ER diagrams and discussing the relationships in your data, because understanding your data is key to being able to write successful queries. What I mean by understanding your data is really kind of a combination of data understanding and business understanding. It's definitely data understanding and asking yourself things like, are there lots of nulls value in this? Is the data made up of string values that were just free form or entered? Or is it concatenated dates and times? But then there's also this concept of business understanding, meaning how do all of these pieces and elements relate to each other? If you're new to this subject area and you've never worked with the data before, it's going to take you a little bit longer to write your queries. Because of this, it's going to take you a little bit longer to figure out how does everything work together, how does it join or relate to each other? Or realizing something isn't actually an integer, it's a string, and what does this mean for your analysis? But it'll always be worth taking the time to understand your data as much as you can before you really start to analyze it. It's important to really understand the relationships and the dependencies. That leads us to our second step, which is the business or subject area understanding. As you start to get familiar with your data, what will happen is that you'll run into questions about the business problem you're trying to solve, the problem or subject or area that you're looking at. I don't know if steps 1 or 2, data understanding and business understanding, are really separate. Usually I'm going back and forth between looking at the data and going back to a subject matter expert or somebody who really understands the core business problem and trying to solve the problem. And I'm asking them more and more questions, going back to the data, then going back and asking more questions. This is essential in being able to really wrap your head around the problem, but also then wrapping your head around the data you're using to try and solve for it. One of the things to be careful for is what I call the unspoken need. You may have a business problem where they say, for example, we want to predict whether or not a customer is likely to buy our product. That seems pretty straightforward and easy, right? But as you dive into the data more, you may start to get questions like, well, what customers? What products? Some of the things that aren't spoken are certain logical exclusions. For example, are there certain customers that should be excluded from this analysis? Are there certain cases where past sales shouldn't be added into this model or shouldn't be counted? This is why you have to walk in between that data understanding and business understanding, because you frequently need to look at the data to get questions, and then you need to go back to the business to understand the problem better. You can think of these steps as 2 different steps, because they're definitely 2 different tasks that you're doing, but you can also think of them as just a back and forth process you're continually doing. This is going to be the most important aspect though. If you can get this and really understand a problem, the query writing will just come easily. If you really understand your data and understand the problem, writing the queries is just like filling in the blanks. It's going back to that concept we've talked about frequently in the course, to slowly do. Slowly wrap your head around the problem. Slowly wrap your head around understanding the data. and the query writing will actually come rather simply. Okay, let's pause there for now. We'll go over some other things to consider in this next video. More to come. So in our last video, we talked about the idea of understanding your data so that you're writing queries that will help you answer your questions. We're going to continue that discussion here. Part of what you'll do when you're trying to understand your data is you'll start to profile your data. This is where you do descriptive statistics. It's also a good opportunity to identify any data quality issues before really diving into your analysis. It's always a good idea to take this profiling step before you finalize any of the data you're extracting. We're going to talk about those steps in this video. After this lesson, you should be able to determine and map out the data elements needed for a query, discuss some of the strategies to employ as you begin to write more complex queries, and explain some common troubleshooting techniques to try in your SQL code when it isn't giving you the results you expect. Okay, so to really understand a problem, you really need to map out what are the exact data elements you need. You need to know the data you're going to go after and understand some of the issues with the data from the profiling you've done. So where do you start with your data and query? If you're always extracting data, it's always going to start with the select statement. So you're going to have to use select and from. What I do is usually write out, okay, where is the data that I need? And then kind of draw out a diagram of the different tables and the pieces of information I need on paper. Basically just creating my own data model and map. I start with this just as the sources, and then from each source I go down and define the fields I need, and then from there I also define how I'm going to join those different sources together. From that point, I'm going to decide if I need to do any calculations. It's just kind of going through a logical process that I go through. But again, you're always going to start with select. I mean, that's the great thing about SQL. It's consistent in that way. What I recommend is to start simple, especially if you're new to the data. Start with just one table, add in more data, add in another table, check your results, and then go back from there. If you're using subqueries, remember to always start with the innermost query, and then work out and build. Start small. That leads us to our next tip, which is test along the way. Don't wait to test your query until you've combined multiple sources together and you have all your calculations done and finished. Think of this as little building blocks. You know, if you write a calculation of the average selling price of something, look at how many values you're getting back for just that calculation from the table, and make sure that seems right. Then combine this result with another table, and then test that. If you know your data, you can dive in a little bit quicker. But this will really make sure that your order of operations is correct. This is key because, as I said before, it's easy to get results back, but getting the right results back that you expect is a little bit harder. Okay, let's talk about troubleshooting. When troubleshooting, it's important to always start small and simple and slowly start to rebuild the query to see where things went awry. It's helpful to start at the basic things first. Okay, I'm getting these fields from this table. Does that work? Yes. Okay, now I'm getting these fields from this table and from another table. What's my join like? Is this working? Okay, yes it is. Slowly start to build it back up in order to figure out where things went wrong. Let's say at this point you're working through a problem and you know your data, you've profiled it, you've tested it, and you've started simple, and you have your query. Be sure that when you're writing it, the next thing to look at is to make sure you're formatting it correctly and commenting it in nicely. I think that clean code says a lot about you. Make sure that it's easy to read. You're using proper indentation, you're commenting strategically where you need to, etc. You never know when you're going to need to revisit your query, or you're going to need to hand it in to someone else and they need to edit it from there. Just keep your code clean. Format your comments where necessary and strategically. Then you want to make sure to review what you've done. A lot of times what happens is you'll write a query, you'll be using it for your model, and you'll be looking at different stats and things like that. Then you need to go back and edit and change that query. Always make sure you review the query to see if anything has changed. Has the data changed? Are the business rules different? Do you need to update and change the date indicators? Does anything need to be updated? In general, be really careful when you're going back and using old queries. Okay, that really takes you through a problem from beginning to end. Again, it all starts with the data and problem understanding. Make sure you spend the time there. Make sure you really are spending the time thinking about what you're doing before you actually start writing the queries. I promise, it will save you time in the long run. Then go through and really understand your data through profiling it. Make sure you're testing along the way and keeping your code clean and commenting. Those are just a few little tips that I can give you. You're fully equipped now to go and retrieve the data you need, which is exciting because the first step in doing data science is to be able to get your data. You now have that in your toolbox. Reflect on these steps and framework when you look at problems and start writing your queries. All right, go and get your data and start analyzing it. Congratulations! You've successfully completed this course on SQL for Data Science. In this course, we went over an extraordinary amount of material. We started simple by going over standard SQL syntax, some standard database terminology, and how to write simple queries to help you select data from tables and work with it. We moved on to discussing methods to filter and sort your data results by using common operators and clauses like where, like, order by, group by, and between. We also spent quite a bit of time talking about subqueries and different kinds of joins. We learned how to use case statements in order to help you categorize your data, and then we ended up going over some specific strategies to keep in mind when you're using SQL for data science purposes. Always remember, slowly do when writing your queries, and I guarantee you that your queries will be cleaner and more efficient. Between all the things you've learned and all the practice assignments you've accomplished, you've come a long ways and learned an enormous amount of SQL and how it's used for the data science field. You should be proud of what you've accomplished. I hope that through this course, you've discovered just how powerful SQL can be in data science and learned a little bit about how fascinating the data science field truly is. I hope that this is just the beginning of your data science journey and you're inspired to do more. Remember, data is everywhere, and the more you know how to use it and use the data to gain insights and make better decisions, the more value you'll be able to provide to any organization you're a part of. Thanks so much for joining me. I hope you take these new skills you've learned and do good to change the world. Best of luck.
Thank you for watching our video. We hope you found it helpful. If you enjoyed this video, please hit the like button below and subscribe to our channel for more videos like this. If you know someone who could benefit from this information, please share it with them. We would love to hear your thoughts on this learning course, so please leave a comment below. Thanks again for watching, and we'll see you in the next video.